Assalamualaikum warahmatullahi wabarakatuh to Mr. Ismail Adam. So today we will present about our project, which is Jackpot Machine. Consists of me, Muhammad Aiman bin Ahmad Shakir, and also Muhammad Rabbani bin Yaakob. Next slide. So for the objective, the main objectives of our project is to make a jackpot machine program and display the result to LCD. The program will be displayed to LCD, and the result of it, the jackpot result, can be controlled by pressing blue button on the nuclear board. So we're moving on to problem statement. Most of the jackpot that have been developed by programming being displayed to big screen, such as a laptop monitor, or as we call it as a serial monitor on a teraterm, for example. Furthermore, it is not displayed in an interactive way. So in terms of size, not all people like viewing things in big screen sizes. So traditionally, displaying jackpot program using serial monitor or teraterm on laptop monitor takes up much space, and sometimes the display looks old with the font sometimes. So although the display technology nowadays keeps expanding, but it cannot be integrated easily into the system, as integration will vary based on each type of display. So with ITC LCD, microcontroller learner or students can display the program in an interactive and small device. The idea of using this type of display is because of its compatibility and easy to configure makes it as a primary choice for students to display any program or system. So I will pass to Rabbani to continue on the next part.
All right, thank you, Aiman. Yeah, I2C LCD. So for STM 32F401 and I2C LCD. The program that been delivered the mention, which is display message whether the user able to get jackpot. The three number are same. Beginning, user will be greeted with welcoming message, and to start the program, need to press the blue button to start the program. On ED, the LED PA5 will toggle, which indicates that the system is ready. So when the system is ready, the LCD then will display message and the three numbers randomized. The display message will contain four conditions. Alright, for the first condition, if all three numbers are different, LCD will display 0. On second condition, if only two numbers are same, it will display nickel. And on the third condition, if the number are the same as chosen, which is 3 in the program, it will display dime. On last condition, if all the three numbers are same, for example, get number 3 as chosen in the program, it will display jackpot. Okay, next, for the block diagram, the STM32 nuclear board is connected to and add as the indication and I2C LCD. Okay. So for the project functionality, list the project specification for each functionality of the project are included for the finder. So for number one, the LED PA5 will toggle at 500 milliseconds. Indicates the system is ready for the user to use. Then after the blue button being pressed, the system will display which is number were limited up until number 3 to the LCD. One is will be displayed at the bottom side of LCD which based on 4 conditions. Next is a project design. So this is the figure of schematic and circuit diagram of the hardware. As you can see, the ground of LCD connect to the ground of Nucleo, VCC connect to 5 volt, and the SDA, which are the blue line, connect to PB7, and SCL, the yellow line will connect to PB6. Okay, next, the project flowchart. Okay, for the flowchart, we need to initialize first. Then, if the press switch 1, it will generate random generator. Then go to random var 0, var 1, var 2. Then we must initialize the condition first. Kocok less than or equal 0. Delay for the 500 millisecond. Yes. Then the condition will update until it reach a max. If yes, it will go to the here the right side. VR1, VR2, VR3. If all VR is equal to 3, it will display jackpot. Any 2 will display time. If equal, any 2 equal, nickel, and the last one is 0. Then the project the coding will go up again at press the blue button switch 1. Okay. Next, for the source code, Aiman will continue the presentation.
Okay, I'll continue on my part, which is on the source code. So we begin our source code and we include standard IO and source string.h, and then we include LCD, ITC LCD H file, and also LED and switch.h file. And then we define S1 as our GPIO read pin for our pin 13 for input button or blue button. And then we define toggle LED, GPIO toggle pin on pin 5, which is our LED. And we define LCD add, and this is our address for our PC F8574 for our I2C LCD. And next is we define character LCD buff as 50, character for TX2 buff 200, and UIT 32T on T0 and T1. And this is for our initial and after condition. And we declare E number for state 0, state 1, and state 2. Next. So in our user code begin 1, we define UIT 80 for kocok 1, VR1, VR2, VR3, STO for state 0, ST1 for state 1, ST2 for state 2, and also T. And then on begin user code begin 2, we write down string copy text2 buff Jackpot Machine, and this will be displayed to Teraterm for indicating that the system is ready. And we're using transmit DMA, Hollywood DMA to display it, and then HGPIO right pin for we reset the pin 5 first, and then we're using LCD initialize LCD clear display, and LCD go to XY, and LCD send string to output our message to our LCD. And then we define T0 to T1 equals to hard get tick. On the while, on the infinite loop, on the while, so for the first is for the initial condition. That's why we're using T0 less than hard get tick. So this is the initial condition when the button is not pressed yet, which we toggle the pin, as you can see on the bottom, which is GPIO pin 5, and that's when that is where we toggle the LED on the initial condition. Okay, next slide. And this is for the next condition, which is after the user press the blue button of PC13. Okay, so on the T1 target date, if state 1 equals to 0, we input the user to switch, which is case, we're using switch case, which is on the state 0. When the user press the blue button, which is S1, it will randomize the number first, and then on state 1, using Kochok 0++ for randomizing the number on VR1 to VR2 and also VR3. And if the user, if the blue button is on the GPIO pin set, ST0 or state 0 will change to state 2, and it will display the number on the first row of the LCD, which is we display as all the three number, which is VR1, VR2, and VR3. And after that, we're using LCD go to XY and also LCD send string to output the message to the LCD. Okay, next. Okay. On the case state 2, we define T1 equals to get T, hard get T, and this is the function to categorize the T number into to display our four conditions. So we're using T equals to 0. So this is the initial condition for our T variable. And if VR1 is equals to 3 and VR2 is equals to 3 and also VR3 equals to 3, it means T equals to 3, which then on case 1, on the case 3, we display as jackpot. And else if VR1 is equals to 3, VR2 is equals to 3, or VR2 equals to 3 and VR3 equals to 3, or VR1 equals to 3 and VR3 equals to 3, T equals to 2, it will display as dine. Okay. On else if VR1 equals to VR2 or VR2 equals to VR3 or VR1 equals to VR3, it will define as T equals to 1, which then it will fall under case 1, which is nickel. So and last, else it will display as 0, and that's why we define it as default for the switch T. And then we're using LCD go to SOS and send string to display the message. And then ST0 equals to state 0 and break. And that's it for our code sources, code source. Okay. Next. So for the outputs, so this is the initial condition when the user not yet press the blue button. So this we display Jackpot Machine metri, and also at this time on this initial condition, we set the pin PA5, which is LED, to toggle at 500 millisecond. Okay, so this is the first condition for 0 condition, which is all three numbers are not same. Okay, next. Okay, this is nickel, which two numbers are same. And also, so this yang ni lah. Next. This is dine. It is when two numbers are same on same number 3 fall for two numbers are same, so it will display as dine. So next, this is the jackpot, which means the three numbers are all same and display, and the user get number 3 for all the numbers. Okay, so that's it, our outputs on 4 conditions. So we advance to conclusion. So to accomplish the project's initial design and construction goal, a jackpot machine was created and built using STM32 F401, a Nucleo 64 board, an I2C LCD, and green LEDs. BA5 on the Nucleo board serve as system and status indicators, while I2C LCDs serve as the monitor, displaying the result and messages. The I2C LCD was chosen as our display peripheral since it was straightforward and easy to use and does not require any additional cables or connections. And also the I2C LCD was chosen because of its display superior to other display devices such as 7-segment 4-digit display. And apart from that, the I2C LCD also requires only 4 wires. In the end, we can confirm that the objective of this project has been achieved and the project is successful. So I think that's all from us. So thank you, sir, for listening. And Assalamualaikum.